talks in this panel session, so raise your questions to the speakers. We have also we have a question here.
Okay. So
Yeah,
it's
please.
okay. So it's for the previous speaker, Camacho. So my question is, how do you define your reference concrete? Or so you did your measurements versus a reference concrete mixture. My question is, did you use some kind of norm for the reference concrete?
No, the reference concrete is an ordinary concrete with water ratio cement 0.65. I think it's a little bit high. So
It is a
yeah.
lot.
No.
Especially if you consider that you are testing pretty much the chloride diffusion coefficient, and 0.65 is a little bit high, so it's quite normal for you to get such really good results comparing anything versus that reference concrete.
The purpose of this sample is to be able to check on time if the system is working. So if I put 0.5 at this moment, I couldn't see probably yet any kind of penetration. So now with this, I know after year and a half that the system is working adequately. It was mainly the goal.
Okay.
But I understand.
And okay, another question for the last speaker. So the carbon nanotube seems really good for certain applications. Do you think the concrete conductivity or resistivity changes that the carbon nanotubes could add? Do you think it could be beneficial, prejudicial? It probably depends on the applications. I can see a lot of applications where it can be useful, but to be honest, on most of them, I would say it's probably not that useful, because concrete is a really high resistive material, and that's one of its good, I would say, characteristics. I don't know if the carbon nanotubes affect it too much or not.
We increase little bit the resistance.
Of the electrical?
Yes, electrical resistance.
Okay,
So
that's really
it's opposite side of what we may expect.
it is. It's actually
Yes,
nice.
and this increase in the resistance is because of their more compact structure of their cement rock, and ionic transport is also reduced.
Yeah,
So
you have less pores, it's more compact.
It's about half a decade of difference sometimes usually we observe for the conductivity. Yes.
Okay, thank you very much.
So finally, please introduce yourself very shortly. Who are you?
I'm a PhD student from Aveiro. I'm a civil engineer, and I'm part of the Lorcinis project. I'm just proud to be here. Okay. And
Do you have a name?
Celestino Gomes, sorry.
Thank you very much. Are there any other questions? We have time.
Good morning. My question is to Maricruz. As we are talking about durability in concrete structures, we wonder what is the durability of these structures. But with relating to structural health monitoring systems, we can embed into the concrete structures. What is the durability? So my question is, we have to wonder about the durability of the self-monitoring we are going to add to this concrete.
Okay, yes, this was one of the comments I was doing, and here in the questions I have here that I asked to you to answer also, I think that is one aspect is important. I believe that we need to monitor our structure, and it's a reality that is coming, particularly some special structures that we can discuss here, which type of them. And the durability of the monitoring system is important. So I think we should have like strategies. If we use embedded sensors, of course we need to know the service life, the durability of such sensors. And until now, the experience is not more than 20 years. But okay, we hope to succeed in the future, it's clear. And in case that the monitoring system with embedded sensor fails, first, we are not using one sensor only. We are using several sensors with several parameters. Not probably all of them we are going to fail at the same time. But in case that there is a fail and one parameter is very relevant, then we can try with the external monitoring systems that with a non-destructive testing methods that already exist, of course. And that is, I think there are two ways to get a parameter that is relevant to analyze the performance of the structure in real time.
Okay, but related to these carbon nanotubes that you use with you additive to the concrete, what is the durability of the self-diagnosis, for example, of this material you add? You have tested the durability of this. How last this self-diagnosis of this additive?
Normally nothing happened with nanotubes. So in concrete, nanotubes or other carbon additive will be embedded by some mineral structure. So the importance is to see how to get the response to analyze some data. In our cases, my example, it's just micrograph analysis. It's people inspecting pillars 2 times per year. They just take micrographs and some 1,000 of micrographs analyzed after that. And they can define, okay, if the density or thickness of cracks quite important, it means that the lifetime of pillar is about 2-3 years. It's statistical, but it's very, very simple method. So if you imagine some more sophisticated device with some higher concentration of carbon additives to have some ultrasonic or other types of response, so it will be very, very stable, the same stability of the main construction. It's the question how to design this device. It's the most important question, I think.
Okay, thank you.
We have time for a last question.
I think that you have to do some few minutes, benefits from the coffee. But I would like to have some inputs from you. Is anybody able to answer or comment something about these questions? Particularly when the investment compensates the cost? I think Esteban gave some comments about that. But this monitoring system is a dream or is a reality?
Osmiller from RISE in Sweden. Maybe one comment which we get frequently from owner of structures. For instance, we work together with the Swedish Road Administration, which has around under their wings 15,000 bridges, which is probably compared to other countries with a denser road system not much. But they are very open to ideas, but they are also very conservative because one point they say is monitoring is fine, but what do we do with monitoring data? We don't want to sit around and evaluate zillions of measured data because we don't have really a good big data evaluation systems. Secondly, consistency of data, aging of data. In your nice presentation, there was also this aspect of age management. I think it was called data age management or data aging management. This is also a problem when a structure is designed for 120 years. How can you read the data after 120 years from the beginning of the structure, structural life? Huh? So, and this is also what they are concerned about. And I think this will cost a lot more development to tackle those issues, to bring it really into practical level. Okay, maybe single large objects, they can be already equipped with monitoring, and it can be done, and they have probably some systems, but I think what those, especially those owners of those structures, are more interested is that they can do also monitoring on minor structures, because those are actually causing a lot of costs for maintenance, or even to going out for inspections. And because it's a mass, it's a number of structures they need to handle.
Okay, I introduced myself twice, so enough. The point is, I really agree on your concerns and what the owners, typical owners, are really focusing on. But what about new potential business models? Nowadays, not many owners are willing to own. Actually, they're willing to lease or even renting, or that is becoming even more popular. You notice in the car industry, in automotive, where they want to ensure a certain level of service. That is quite a standard. If we don't try to implement functionalization of raw materials, to really place this as a scenario where you can really go for the renting of a bridge or all the kind of infrastructures where the exploitation is the responsibility and the maintenance, of course, of third parties. This is a model that we cannot get in. We need to deliver exactly those reliable technologies that can make this change of the paradigm that we are facing now. And this kind of situation with the Internet of Things and all this stuff is a reality in many areas, but not in construction side. And we need to move forward. This is when we talk about industrialization 4.0. That is one of the main topics, how we made more, or a bit smarter, not the smartest, I would say that, but a bit more smarter materials, able to give some information, to diagnose themselves, to be more predictive in terms of budgeting, investment, and the exploitation of the business models. That is something that we need to introduce also in the mindset of many researchers, how we move forward in this direction, how we bring this knowledge to make tangible and real these kind of scenarios. But I fully agree that as an owner, if I make this exercise of empathy, and if I were an owner responsible for a massive budget, but many options to address every single problem, I need to be really, really efficient in the allocation of my resources and my budget.